functions, two distinct complete functions. First one is sine function, and the second function is x square plus 1, that is algebraic. Correct? We can split it. That's why to find the derivative, if f of x is a function, we can solve it by using product rule. Clear, right? These two are two distinct functions. Okay. Suppose if it is composition, I told you sine of x square plus 1. So when you split it, sine then x square plus 1. X square plus 1 is algebraic function, that is complete. But sine is incomplete, its angle is not there. Sine is what? X square plus 1. Alright. So when you split it, we won't get here two complete functions. That's why this is not solvable by product rule. Here it is a composition, so we have to apply chain rule that we have studied in the last class. So chain rule is only for composite functions. If you get these kind of two functions, we can simplify by using product rule. Getting clear or not?
Video is very much laggy, sir.
Lagging.
Yes.
Buffering, sir.
Just wait for a minute. Hello.
Yes, sir.
Yes, sir.
Is it clear now?
Yes, sir.
Yes, sir.
Okay. Now also it's breaking.
No,
No,
sir.
sir.
It's
Now clear,
fine
right?
now. Yes,
Yes,
Okay.
sir.
sir.
Okay. Okay. Yeah. Okay. So do you understand these two? Product rule, chain rule, clear?
Yes, sir.
Okay. Now thereafter we have studied what? Tell me. Implicit functions and explicit functions, right?
Yes,
Okay.
sir.
So what are explicit functions? Explicit functions. Tell me.
Which are in the form of y is equal to fx.
Very good. Very good. If you can write any function y is equal to f of x, or easily we can say that in the function we have only one variable, right? So that kind
Yes,
of
sir.
functions are called explicit functions. So what is implicit functions? Function consists of two
Two
variables,
variants.
x and y. That is f of xy is equal to a constant form. Or example, we can write x square plus xy plus sine x. Okay, see in this function we have two variables x and y. Okay, so these kind of functions are called the implicit functions. Clear, right? Okay,
Yes,
so
sir.
how to
Yes, sir.
differentiate implicit functions? Differentiate both sides with respect to x. Clear, right? Differentiate both
Yes,
sides
sir.
with respect to x. Okay.
Yes, sir.
Now next we are going to study logarithm differentiation. Okay. Yeah. So what is the use of logarithm differentiation? See, everywhere we can't use which one, chain rule. Everywhere we can't use product rule, or everywhere we can't apply the property of implicit functions. Okay, these are for different purposes only. Clear, right? Okay, when we have that kind of function, there we have to use that rule. Is it clear, all of you? Okay.
Yes,
Yeah.
sir.
Now see, listen, very very important, all of you understand the thing, then easily you can solve problems in integration also. Suppose we have these are the three kinds of cases: x raised to n, e raised to x, a raised to x. Okay, so these three things have exponents. Note it there anywhere. Means when I explain the same time, you note it there, so you will get it. So listen, understand things. X raised to n means you know that d by dx of x raised to n is n into x raised to n minus 1. D by dx of e raised to x is the same e raised to x. D by dx of a raised to x is a raised to x into log a to the base e. These are the properties we are having, right? Okay.
Yes.
See, I can use this property when n is an integer. Any integer we are getting, you can use this property. Example, if I write sine x the all raised to n, okay, that is sine square x. This is possible. Is it clear getting? If I write log x the all raised to 7, this property is possible. Do you understand? If I write tan raised to 7x, okay, clear? If I write e raised to 2x, this I can write e raised to x the whole square. Okay, clear on what all of you? In all these cases, so what you have to understand, base whatever things, x is what? X is a variable. Variable means something that can vary. You can take anything for x. Okay, what are the functions we are having? Trigonometry function is there, then inverse trigonometry function is there, logarithm function is there, exponential function is there. Okay, these kind of any function we are getting, we can solve. Only condition is that what n should be an integer. Power is an integer. We can use this property everywhere. Do you understand? Did you get the idea?
Yes,
Clear or
sir.
not?
Yes,
Okay.
sir.
Okay. Second case you go. When you consider the second case e raised to x, here see base you have to get. If you want to use this property, e raised to x property, base should be e. Power variable check where we have x. This only can vary. Variable means something that can vary. So where you have x, that all places you can replace by something. So if it is e raised to x, instead of x you can write, if you want, tan inverse of x. Clear? E raised to x square you can write. E raised to log x you can write. E raised to square root of x raised to n plus 1 you can write. Do you understand? These all we can solve by using this property. What is the condition here? Base should be e. Here what is the condition? Power must be an integer, which means 1, 2, 3, 4, 5, 6, any number, 100, anything you can take. X can vary here. X if you want log x, tan x, square root of x raised to n, root x, anything you can consider. But power must be an integer. Here base should be e. Power anything you can take. See x. X is a variable, so anything you can consider. Did you get the idea? Okay,
Yes, sir.
and go to the third case, a raised to x. In the last class, we solved certain problems, 2 raised to sine x or something, right? These kind of questions we solved, right? So consider
Yes, sir.
here base, base should be a constant, power anything you can take. In all such cases, we can use this property d by dx of a raised to x. Clear, understood? Okay,
Yes, sir.
but where we are going to apply logarithm differentiation. Understand things? See, I have a function, base is like this, base is x. Okay, just I am taking base is x. So if base is x, power should be an integer, then only you can use n into x raised to n minus 1. If power we are getting sine x, you consider. So what you have to get power of x? It should be an integer. But here this is also a function. So you can't solve by using this property. Did you get the idea? Okay. So easily I can say when the given function is of the form function raised to function, that is f of x raised to g of x. In this case, to find the derivative, we can use logarithmic differentiation. Note it there. Okay, where we have to use logarithm differentiation, function raised to function. Okay, so please, yeah. See. Avardhan,
Yes, sir.
hi, what happened? Why are you
Sir,
late?
there was some network issue. Sir, there was no network issue. That was I was not able to join.
Okay, yeah. See. All of you listen. If the given function is of the form, given function f of x is of the form u of x raised to g of x or u of x raised to v of x. Okay, that is u of x and v of x both are functions, or you can easily write function raised to function. Okay, function raised to function. Where you have function raised to function form, there you can write or you can apply logarithm differentiation. My question is this one: 5 raised to cos x. Can you use here logarithm differentiation?
No, sir.
No. Why? Here this is a constant, so it is of the form a raised to x. Did
A
you get
raised
the
to
idea?
x.
Yes,
Okay.
sir.
Yes, sir.
Okay. So e raised to log x. Can you use here logarithm differentiation?
No, sir.
No,
No,
sir.
No.
sir.
E is a constant. It is of the form e raised to x. It has property. Okay. Okay. Now my next question is tan inverse of x, the whole square. Can you use here function raised to function
No,
form?
sir.
No,
No.
sir.
No, sir.
It is
No,
an
sir.
integer, right? Did you get the
Yes, sir.
idea? Okay.
Yes, sir.
But if it is tan inverse of x, the whole raised to sine x, here
Yes, sir.
Logarithmic
you
differentiation.
can apply. Okay.
Yes.
So understand that in the given function, base, exponent, both are functions in this type. So you can use their logarithm differentiation. So how to solve these kind of problems? If you understand the given function is function raised to function form, directly what you have to do, you don't take derivative on both sides. Okay. First you have to take logarithm on both sides. Okay.
Okay,
In the
sir.
last class we have studied the properties of logarithm, right? Okay. So when you take logarithm on both sides, do with me all of you. Come on, follow. So take logarithm on both sides. So when I take logarithm on both sides, left side you get log f of x. Right side it is going to be log of u of x
U of X.
raised to v of x, right?
Yes.
Yes, sir.
Okay. Now, which property of logarithm you can see here? We have studied some properties, right? 3
The
general
log
properties and 2 base change formulas. Yeah.
log b base to a is equal to b log a.
Log m raised to n form, correct, right?
Yes,
Yes,
sir.
sir.
Log m raised
Yes,
to n
sir.
form, right?
Yes, sir.
Okay. Log m raised to n is n log m.
Log
N log m. Third property. Third law. Check it. First law is log mn is equal to log m plus log n. Second property is log m by n is equal to log m minus log
Yes,
n.
again.
Third property is log m raised to n is n log m. Third property we have to apply here. So
Okay,
by
sir.
using third property, how to write log m raised to n? That is n. That is
Log
v of x. Log
u of x.
u of x. Clear?
Yes, sir.
Okay. Now, what should we do next? Now you got two functions. V of x is one function, then log u of x together one function. That is, it is a composite function, log of u of x. It is not log x into u of x, log of u of x. So this you have to consider first function. This is second function. Is it clear? Two
Okay.
complete functions you got. Now, what we have to find here? Find the derivative of the function. So I'm going to find derivative. That is, differentiate both sides with respect to x. Next step. Okay.
Okay, sir.
Differentiate, right? Differentiate both sides. This is the theory part. Okay. This is the way we have to solve all the questions. Differentiate both sides with respect to x. So you get d by dx of log of f of x, that is equal to d by dx of first into second. Okay. These two functions. Okay. Yeah. Now, what is derivative of log x? Chain rule we have studied. So what is derivative of log x?
1 by x.
1 by f
1
of
by x.
x.
So 1 by, instead of x, you have f of x. So you understood that f of x is a function, right?
Yes,
Yes.
sir.
That's why we have to differentiate f of x also. So derivative of
Yes.
f of x is going to be f dash of x. Is it clear?
Yes,
Yes,
sir.
sir.
Okay. Now, right side, there are two functions, first into second. That's it, we have to solve by using product rule.
Product
Okay.
rule.
So when you
Okay.
take product rule, derivative of first function, that is v of x is the first function. Derivative of v of x is v dash of x
Into
multiply with the
ux.
log u
U
of x.
x.
Very good. Okay. Plus first function v of x into derivative of second
Derivative
function.
of
Okay.
log.
That is derivative of log x is 1 by x.
1
That
by
is 1
x.
by u of x. Then you have to differentiate u
U of
of
x.
x. So u dash of x. Clear?
Yes, sir.
Together I have written here. Chirag, is it clear?
Yes, sir.
Product rule.
Yes, sir. Yes, sir.
Derivative of
Clear.
first function. Derivative of first function into second function. First function is v of x. The second function log u of x. So
Log x.
derivative of first function into second function plus first function is v of x into derivative of
Derivative of
second function.
second.
So derivative of log x. Log x is 1 by x. That is 1 by u of x. Then differentiate u of x. So derivative of u of x is u dash of x. Is it clear?
Yes, sir.
Okay. Over. Finished. What we have to find? You have to find dy by dx. That is f dash of x. Dy by dx is same as what? F dash of x, right? Derivative of the function. So this you want to find. So to get f dash of x, what should we do? This f of x we have to transpose. So we get here. Can you see if I write here?
Yes, sir.
Okay. So f dash of x is equal to, I am transposing this f of x. So on the right side it will be f of x into v dash of x into log u of x plus v of x into 1 by u of x. That you can write v of x by u of x into u dash of x. Is it clear? Okay. Now in the last step, what you can do? Just a resubstitution we can give. What is this f of x? This f of x is u of x raised to v of x over. That is a final answer. Instead of this v of x, you will get u of x raised to v of x. Do you understand the theory part, all of you?
Yes,
Okay.
sir.
Yes, sir.
So this is the way we are going to solve all the questions. Okay. Yeah, just note it there. I'll give one question.
Question.
Okay. Let's start. Write the question. Differentiate the following with respect to x. Differentiate the following with respect to x. Differentiate the following with respect to x. First question. X raised to log x. X raised, okay, you do one thing, x raised to sin x. Try x raised to sin x. First you try with the simple questions. After understanding the concept, go to the higher order questions. X raised to sin x. Okay, see, listen, do with me one question. So you will get it clearly. Hello, what is the first step? if you get a function, you can write the function as either f of x or y. Okay, which one is easy for you? Y or f of x? Y.
Why?
Okay.
Y.
So let y is equal to x raised to sin x. Do you understand, all of you? Here we have to
Yes, sir.
we have a function raised to function.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, see, x base x. If base is x, power we have to get an integer, but it is not an integer, it is a function. So function raised to function form, you can solve it by using logarithm differentiation. So next step you have to write taking logarithm on both sides. Taking logarithm on both sides. Taking logarithm on both sides. Okay, take logarithm. Log y is equal to log x raised to sin x. Got it?
Got it, sir.
I say tell me which form is this one? Which form of logarithm is given here?
Log m raised to n.
Log m raised to n. What is log m raised to n?
And log
So
m.
n log m.
N log
Log
m.
m.
Very good. Okay. So this can be written as sin x into log x.
Log x.
See all of you, you got two different functions, distinct functions. So product of two functions, right? Now we have to find the derivative. Now it is easy. Differentiate both sides with respect to x. Next step, right? Differentiate both sides with respect to x. Vansha, is it clear?
Yes, sir.
Okay. Avardhan, Akshya,
Yes, sir.
Yes, sir.
Chris, Pankaj.
Yes, sir.
Yes, sir.
Okay, yeah. So differentiate both sides with respect to x. D by dx of log y is equal to d by dx of sin x into log x. Okay, check. In the previous class, we discussed the same thing. See, this is x, this one is y variable. Both are different, right?
Yes,
Yes,
sir.
sir.
Yes,
So
sir.
first, after applying the property, we have to differentiate y also. Don't forget that, okay? Okay. So tell me, derivative of log y.
So 1 by
1 by
y
y.
into
1 by
dy
y
by
into dy
dt.
by dx.
dy
Y
by
into dy
dt.
by dx.
By differentiate y also, so dy by dx
dx.
dx.
is equal to here it is clear, right? It is
Yes,
not
sir.
Yes,
sine
sir.
of log x, sin x into log x. So product rule. Come on,
Product.
apply product rule, all of you. That is easy for you. Come on, try. Got it? Derivative of first
Yes,
function,
sir.
that is d by dx of sin x into second
1 by
function log x plus first function sin x into d by dx of log x.
Log
Okay.
m.
Log x.
Yeah. Now we have to find here dy by dx, right? That's why y we
Yes, sir.
have to transpose. So dy by dx is equal to y when I transpose y into the whole thing. Derivative of sin x is cos x
Cos x.
Cos x.
log
Log
x.
x plus sin x.
Sin x into derivative log x
1
1
by
by x.
1 by x.
Okay, now you have to give resubstitution. What is y in the question?
just x sin x.
X raised to sin x. So dy by dx is equal to x raised to sin x into cos x into log x plus sin x by x. Over, finished. Simple. Okay.
Yes, sir.
So when you get higher order questions, functions will be distinct like that. Here simpler functions they have given, but it will be little bit complex. But property is same, theory part is same, exactly same. Okay. Yeah. Okay. Do then next question. x raised to x cos x. X raised to x cos x. Try this one. Ayush, Chirag,
Yes, sir.
hello. Tell me if there is
Yes,
any
sir.
doubt. Okay, if you are not getting, ask. I will explain that. Okay. Yeah. Avardhan,
Yes, sir.
Avardhan. Actually, I did not see the message. Okay, that's why. See, you do one thing. Whenever you send a message,
Yes,
right,
sir.
just give a missed call also. Then I can easily
Okay, sir.
understand that. Okay. I will check message.
Okay, sir. Okay, sir.
Okay. Ayush, could you please help me? Y is equal to. Okay. So function plus to function, right? Taking log down both sides. Okay. Log y is equal to log x raised to x cos x, right? Okay. Now it is of the form log m raised to n. That's why n log m. N is x into cos x into log x. Is it clear, Giri? So you have log y is equal to x into cos x into log x. Did you get the idea?
Yes, sir.
Okay. Now we have to differentiate on both sides. When you differentiate, what you have to do? Twice you have to differentiate. So you have to group any two functions. Any two functions you can group. So I'm going to take x cos x as first function and log x as second function. Did you get the idea? Otherwise, cos x log x you can take second function, x first function as you wish. Okay. Yeah.
Yes, sir.
So differentiating both sides with respect to x. So d by dx of log y is equal to d by dx of x cos x first function into second plus first into, that is x cos x into d by dx of second function log x. Clear? Now left side derivative of log y,
Sir, 1 by
One
y
by
equal to
y.
dy by dx.
dy by dx. Okay.
By dx.
Here listen. Once again you have to apply product rule. When you apply product rule, see this is a common thing for log x is common for everything. That's why this you must write it in bracket. Clear? So derivative of x 1 into second function cos x plus first function x into derivative of cos x sin x minus sin x, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay. Multiply log x plus x cos x into derivative of log x 1 by x. These two cancel. Now this y you can transpose dy by dx is equal to y into y is common for everything all. Now you have to multiply log x into bracket. So cos x into log x. Here you will get plus into minus a minus. Okay. X sin x log x. Last there is plus cos x. Okay. Now in the last step you have to give resubstitution. What is that? this y is x raised to x cos x over. Getting or not? Clear or not? All of you.
Yes, sir.
Yes,
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 sir.
sir.
Last, don't forget this one, okay? Otherwise, you may lose half mark. So instead of y, give the given function x raised to x cos x. Okay, right. Right. Next question. Log x raised to cos x. Speed up, speed up. Log x raised to cos x. Got it?
Yes, sir.
Okay. So see, y is equal to log x raised to cos x, function raised to function. So take logarithm on both sides. Log y is equal to, you will get log of log x raised to cos x. M raised to n form, that's why it is going to be cos x into log x. Write carefully, log x. Okay. Now differentiating both sides with respect to x. So d by dx of log y, that is equal to d by dx of cos x into log x. Okay, so only two functions. First one is cos x, second function is log of log x, but log of log x is composite function. Okay, now when you differentiate, we get derivative log y, you know that 1 by y dy by dx. Okay, derivative of first function cos x, that is minus sin x into second function. I'm writing directly, okay? Derivative of cos x minus sin x into second function. Second function is log of log x, okay? Plus first function, that is cos x into derivative of second function. So first derivative of log x. See, listen. When you differentiate this one, you know that from left side we have to start. Then you have to consider log x as x only. So derivative log x 1 by x.
Log
What
x.
instead of x? Log x. Then differentiate
1 by
log x
x.
also. When you differentiate log x, you will get 1 by x.
1 by x.
Okay. Then transpose y, it will be dy by dx is equal to, see, you can write it in any order. Here it is minus, right? So I am going to write this as first. So when I write this one as first, it will be y into cos x by x log x minus
Sin x.
sin x into
Log of log x.
log of log x. Very good. Yeah. Now last step, give resubstitution for y. That is log x raised to cos x. Clear? Completed.
Yes, sir.
Yes, sir.
Okay. Next one. X plus 3 the whole square into x plus 4 the whole cube into x plus 5 the whole raised to 4.
Oh.
Do you know how to solve this question? Any idea?
No, sir.
Okay. See,
By using log.
listen, all of you. Very easily you can solve. See, traditional way how to solve. How you people are going to solve. Earlier, the same one question when we had three different functions we solved. We grouped first two and taken as one. Then the second function. Clear, right? Then what derivative of first into second, that is equal to derivative of first into second plus first into derivative second. By using product rule, you solve. But here, what is going to happen when you solve by using product rule? Maximum till 3 you can solve. But if it is 4 functions, 5 functions, it is a tedious process. The reason is that you consider that in the first case, when you group these two, there you will take product rule. Okay? And consider if you have 4 functions, you have to group any 3, then consider the last function. So in such a case, what we have to do? Again, we have to group 2. So it is very lengthy. So to resolve this, what we can do? We can use logarithmic differentiation. So how to solve this by using logarithmic differentiation? Consider the given function as y. Here, do with me. Come on. Take the given function as y. Then you have more than 2 functions, right? Product of more than 2 functions. So taking logarithm on both sides. What you will get? Log y is equal to log of x plus 3 square, x plus 4 cube, x plus 5 raised to 4. Okay, product of all. So here, can you identify the property which we are going to apply? 3 main properties we have studied. First one, log m into n, then log m by
Log m
n,
plus
then
n.
log m raised to n. Huh?
Sir, log mn.
Log mn, very good. See, here it is 3 functions are there, so that doesn't matter. N number of functions we have, you can use this property. Just note it there. Log m into n into p can be written as log of product of functions is equal to sum of their logs. If product is a sum, so log m plus
M plus log n plus log p.
log b. Okay, very good. Note it there. Okay. Come on. Now you use the property. When you use it, we get log x plus 3 square plus log x plus 4 cube plus log x plus 5 raised to 4. Did you get all of you?
Yes,
Okay.
sir.
So again check separately terms. Which property you can apply here?
Log m raised to n.
Very good. In the second step, you can roll log m raised to n property. That is n log m. Come on, apply. So you can write it as 2 log x plus 3 log m raised to n log m. That is 2 log x plus 3 plus 3 log x plus 4 plus 4
But
log
no.
x plus 5. Okay. So you got in simplest forms. That's why it is easy to differentiate now. Nothing is there. Differentiating both sides with respect to x, directly you will get the answer. 2 is constant. All the constants we can take outside. In the first part, 2 you can take outside. Derivative log x 1 by x. Clear. Here 3 we can take outside. Derivative of log x plus 4, that is 1 by x plus 4. This also same. Later you have to transpose y. That's going to be a final answer. Come on, try.
Yes.
Vansha,
Yes, sir.
is it clear?
Yes, sir.
Should I explain once again? Any step?
No, sir.
Pankaj?
Clear, sir.
Okay. Krish?
Clear, sir.
All of you, okay, right?
Yes, sir.
Yes, sir.
Differentiating both sides with respect to x. So d by dx of log y is equal to, okay, so we get 1 by y dy by dx equal to, here 2 is constant, I am taking outside, derivative of log x 1 by x, that is 1 by x plus 3. Later here I am not writing anything. Do you know what is the reason?
Yes, sir. So
Why?
differentiation of x is equal to 1.
Okay, very good. See, 2 taking outside, it is composite function. So derivative log x 1 by x plus 3. Then if I differentiate x plus 3, I am going to get derivative of x is 1, constant 3, 0.
0.
So nothing is there to write, that's why. But instead of x plus 3, if it is x square plus 3, then you will have 2x plus 0. Getting or
Yes,
not? Okay.
yes, sir.
So that very carefully you have to do 3 into 1 by x plus 4. Linear function, that's why that only, plus 4 into 1 by x plus 5. Now y you can transpose, dy by dx is equal to y into 2 by x plus 3 plus 3 by x plus 4 plus 4 by x plus 5. Later, you have to give substitution for y. What is y? This all thing. This one. This all you have to write. Don't forget to add that step, okay? That is important. So give here x plus 3 the whole square into x plus 4 the whole cube into x plus 5 the whole raised to 4 into this whole thing. No need to cross multiply or take LCM there. Okay, this is going to be the final answer. Got it?
Yes, sir.
Okay, let's go to next question. Okay. Next one, square root of x minus 1 into x minus 2 divided by x minus 3 into x minus 4 into x minus 5. Come on, try it. How many of you know how to solve this question?
So we will take power 1 by 2.
Okay, very good. Exactly. How to do this? What is square root actually? Listen, if I write square root of 2, this is 2 raised to, this is called radical form. Its a corresponding exponential form is 2 raised to 1 by 2. If I write cube root of 5, the meaning is 5 raised to 1 by 3. Is it clear? So when you get in this form, always you convert to this form, that is in exponential form. Did you get the idea? So first you can write it as, I am going to write, let y is equal to the given function, and that can be expressed as x minus 1 into x minus 2 by x minus 3 into x minus 4 into x minus 5, the all raised to 1 by 2 square root. You check the number here, okay? If it is square root 2, 2th root, then nothing will be there. Other all means 3 or 4 or 5, you can see a number here. Okay, so check that always. Now it is in exponential form, clear, right? And moreover, consider here it is a complex function. You can solve this also by using x raised to n form. Did you get the idea? Okay, root x, you know that, right? Derivative root x is 1 by 2 root x, like that. But the problem you are going to face, that is a tedious process. It will be very lengthy. Okay, so to avoid that difficulty, what you can do? You can use here logarithm. Okay, so take logarithm on both sides. Log y is equal to log of all these things. Okay, now check the property log m raised to n. M raised to n. Log m raised to n is, tell me,
N log M.
n log m. Okay. Others, are you sleeping? Hello, hello.
No, sir.
No,
All are
sir.
there, right? Ah, okay, okay, okay. Okay. So now you will get here 1 by 2 into, that is n into log m, x minus 1 into x minus 2 by x minus 3, x minus 4 into x minus 5. Clear? Okay. Now, next what you will do here to simplify this? How to simplify the remaining steps?
Sir, we will use the formula log m by n.
Log m
Very good.
minus log n.
Log m by
Equation
n.
log.
Yeah. When you see this one, 1 by 2 is constant, always we have to take outside. But when you approach the second function, you can see here something by something, right? That is log m by n form. This one. Log m by n form. Log m by n is log m minus.
M minus log N.
Very good. Apply the property. So 1 by 2 into 1 by 2 is common for everything. So you take that outside into log m minus log m. So log m is, instead of m means numerator. So x minus 1 into x minus 2 minus log n, that is log of x minus 3 into x minus 4 into x minus 5. Okay. Can you tell me what will be the next step to solve this? What is
Log
going to be
m
the next
into
step?
n.
Very good. When you see the first part, here you can see log of something into something, right? X minus 1 into x minus 2. So log of product of 2. So log of product we can solve by log m into n. How to write?
Log m plus
Log
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 M
n.
m plus
plus
log
log
n.
N.
Log m plus log n. So
Log n.
here we get log x minus 1 plus log x minus 2 minus of, in bracket, means this minus is common for everything, that's why log x minus 3 plus log x minus 4 plus log x minus 5. Okay. Now we simplified everything, so directly we can differentiate, right? Differentiate both sides with respect to this. While differentiating this, you can separate, you can multiply minus into bracket. It's very easy chapter. See, you practice. Okay, you do one thing today. If you get time, means after the class, at least half an hour you spend for that. You finish your exercise 5.5. Okay, all the questions. And previous exercise also, just to go through that. So once you understand, right, differentiation is very easy. Seriously, I'm telling. If you study that basic properties, you can solve each and every. Means concept also you have to get concept in the sense what explicit function, implicit function, function raised to function. Okay, these ideas if you are getting, you can solve all the questions. No need to worry anything about it. Integration is more easier than this one. Okay, so practice is very very important. always you do one thing. Whenever I explain here, right? Suppose if you are not getting something, just write it in bracket. Okay, something. How you are understanding that? What explanation is required for that? That you just write in the bracket. Otherwise, what is going to happen later when you just come up with this, you won't get that. So in the margin or bracket, you just note that which property we applied, what we have done there. Okay. Okay. Now last, differentiating both sides with respect to x. So derivative log y 1 by y dy by dx is equal to 1 by 2 constant we are taking outside. So this 1 by 2 is common for everything. So you must write it in bracket. Derivative log x 1 by x minus 1. No need to differentiate x minus 1. The reason is it is linear. Okay. Then plus 1 by x minus 2. Then minus 1 by x minus 3. Minus 1 by x minus 4. Minus 1 divided by x minus 5. Okay. Then later dy by dx is equal to 1 by 2 y, or you can write y by 2 into these all things. Then resubstitution dy by dx is equal to, what is that? Tell me. 1 by 2 into square root of, what you will get? X minus 1 into x minus 2 by x minus 3 into x minus 4 into x minus 5 into all these things. That is going to be the final answer. Completed. Okay. So next question is x raised to x minus 2 raised to sin x. Come on. Next question, x raised to x minus 2 raised to sin x. Yeah. This one you are talking about. Okay. Ah. Hmm. Okay. These all thing as 1 by 2, right? Okay. But the function, now here what you should do, the given function always you take as y. Clear, right? The standard form, what is given in the question, that you have to write here. Clear, getting? Even if you write raised to 1 by 2 also, your answer will be right. Okay. But normally what you have to do, this is going to be the given question. This part, why? Arshia, do you complete?
Yes, sir, I'm doing.
Okay. Do you understand how to solve this question, all of you?
Yes, sir.
It is not same as the previous questions. That's why I asked. Understood? It is not same as the previous question. See, all of you, please go to all the questions we solved. You can see there product of two functions. Clear, right? Check it. You haven't solved any question of the kind means sum of two functions or difference of two functions. Check everywhere. You got product of two functions. In the product, you got sum. That means, example, x plus 1 into x plus 2. Actually, what we have here, product of two functions. This we won't consider here. That is a part of a single function. Clear, right? This plus. Correct, right? Did you solve any question of this kind? X plus 1 minus x plus 2 or x plus 1 plus x plus 2, this kind of question? Operator plus minus like that? No, right? Okay. So what should we do if you get these kind of questions? See, x raised to x is one function, 2 raised to sine x is another function. So you can write in the beginning the given function as let y is equal to, but after that you don't take immediately logarithm, because if you take logarithm on both sides, say log y is equal to log of m minus n form. You don't have log of difference of two functions. Log of product or log of quotient you have, and if the result is going to be, what is that? Sum of their logs or difference of their logs. Log of difference is not there. So in this case, how to solve questions? If you have this kind of any question, you have to take separately the functions as u and v. If we have three functions, u, v, w. Get it? So all of you please note it there. Let y is equal to the given function. Then take there. Let u is equal to x raised to x and v is equal to 2 raised to sine x. Okay. So that the function is going to be in the form, therefore y is equal to u minus v. Okay. What we have to find here? Tell me. Dy by dx, right? Find the derivative of the function, that is dy by dx. So dy by dx is equal to derivative of u minus v. So difference rule, when you apply, what you will get? Du by dx minus dv by dx. Is it clear? That means differentiating both sides with respect to x. Okay. Y is equal to u minus v, differentiating both sides with respect to x. So what are the things required here? Du by dx and dv by dx. U and v we have. So separately you have to differentiate u and v. Okay. And substitute in this. So take this as equation number 1, all of you. So first I am going to take, consider x raised to x. Okay, u is equal to x raised to x. Then you understood that this is of the form function raised to function. That's why taking logarithm on both sides. So log u is equal to log x raised to x. Log m raised to n form. So log u is equal to x log x. So product of two functions you got. Now differentiate both sides with respect to x. Chiraga, if you are feeling any difficulty, tell me that. Okay, I will explain.
Okay, sir.
Avinash, what happened? Confusion?
No, sir. Solving,
Okay.
sir.
Okay, try. Okay, first you try.
Okay.
Ayush, where you stuck? This one, this part. Okay, yeah, yeah. See, if yeah, listen. And b is equal to 2 raised to sine x. Okay. Now what you have? The given function y is going to convert in terms of u and v, right? So y is equal to u minus v. Y is equal to u minus v. The last. Getting this, I have taken u. This I have taken v. So y is going to be y is equal to u minus v. That is the last step. Then differentiating both sides with respect to x. So you will get equation number 1. Then we are going to find one by one. That means first I want to find du by dx. If I want to find du by dx, first you consider u. U is equal to x raised to x. So you understood that function raised to function. Clear? Yeah.
Sir, what is the answer, sir?
Final answer.
Yes, sir.
Final answer. 1 minute. Final answer is
One.
x raised to x into 1 plus log x minus 2 raised to sin x into log 2 to the base e into cos x.
Yes.
Yes, sir.
Got it?
Yes.
Yes, sir.
So differentiating both sides with respect to x. Then it will be 1 by u du by dx. Okay, here we have product rule, right? Derivative first function 1 multiply with the log x plus first function x derivative log x 1 by x. So these two cancel, right? 1 you will get. Then final we have du by dx is equal to, I am transposing u. So u into, I can write x by x 1. That I am going to write first. So 1 plus log x. So the final answer for du by dx, that is u. U is what? X raised to x into 1 plus log x. Did you get all of you?
Yes, sir.
Okay. Now we are going to do second one. Second one is 2 raised to sin x. Okay. That is v. So v is equal to 2 raised to sin x. Should I take here logarithm?
No, sir.
No need to take logarithm. What is the reason? This is of the form.
Function.
This is a constant raised to function. That is a raised to x form. Okay. So d by dx of a raised to x is a raised to x into log a to the base e. Directly we can find it. No need to use logarithm there. Even if you use logarithm also, you will get the same answer. But no need to do that. Within what 1 or 2 steps, you will get the final answer there. So we can write directly dv by dx is equal to derivative a raised to x. See, a raised to x into, that is 2 raised to sin x into log a to the base e, that is log a is 2 to the base e. Clear, right? But here most of the students are going to make mistake is what? Sin x you won't differentiate. Did you get the idea? After doing a raised to x, what is a raised to x? Derivative a raised to x is a raised to x into log a to the base e. Chain rule we have studied, right? So what is left over? Sin x is left over. So you should differentiate sin x also. Check it, all of you. How many of you have done that? Okay. Now, derivative sin x is going to be cos x. So you will get the answer 2 raised to sin x into log 2 to the base e into cos x. This is your dv by dx. What is the question? Find dy by dx. That is equation number 1. So when you substitute du by dx and dv by dx in equation number 1, you will get the final answer. So last you can write, therefore equation number 1 becomes, dy by dx is equal to, instead of du by dx, this you can write, that is x raised to x into 1 plus log x, then minus dv by dx is 2 raised to sin x Do you complete all of you this part? Can I clear?
Yes, sir.
Completed.
Yes, sir.
So 2 raised to sin x into log 2 to the base e into cos x. Okay, fine answer. Okay. Yeah. Do one more question. X plus 1 by x raised to x plus x raised to 1 plus 1 by x. Ayush, concentrate here. Don't do for any other work. Completely concentrate here, okay? Come on, come. It's very, very important. That's why I'm telling. Later you won't get the time. Now, how much you can finish, that will be a good work for you. Save time always, okay? This also you understood, right? Not product of two functions or quotient of two functions, sum of two functions. This is first function plus second function. So take first of all the given function as y. Yeah, same. Because these two are connected by plus sign, right? Not product, multiplication or division. That's it. So you can take let u is equal to this function and v is equal to this function. When you take u and v, it's going to be y is equal to u plus v. We need to find dy by dx. So differentiate both sides with respect to x. Dy by dx is du by dx plus dv by dx. Your equation number 1. Very carefully you have to do this one, okay? Means you see the type of the function. One is a function, then reciprocal, then all raised to x. When you take logarithm, little bit of complication will be there. So very carefully you have to solve that. Avardhan,
Yes, sir.
did you get the solution?
Yes, sir, for U.
Okay, you got it. Okay, so here the first one, if you consider u is x plus 1 by x raised to x. Function raised to function. So take logarithm on both sides, right?
Yes, sir.
So log u is equal to log of x plus 1 by x raised to x. Log m raised to n. So its result is x into, that is n into log m. So we get log m raised to n log m. Correct, right? Okay. Now, when you consider the right hand side, you know, here we have product of two functions. X is the first function, log x plus 1 by x is the second function. So differentiate both sides with respect to x. So derivative log u 1 by u du by dx is equal to product rule. Derivative first function x is 1 into second function log x plus 1 by x plus first function x into derivative of second function. So first derivative of log x. Derivative log x 1 by x. Should I write one more step here? Write carefully. If there is any confusion, just note it there. Derivative of x, that is 1 into second function. Product rule plus first into derivative second. So du by dx is equal to u transposing. So u into log x plus 1 by x plus x into, very easy, simple. Derivative of log x 1 by, instead of x
X plus 1 by x.
1 by x. Now you should differentiate x plus
1
1
by
by x.
x.
Okay, so you know the property of both of them. Derivative of x is 1. What is derivative 1 by x? Property we have written.
Sir,
Minus
minus 1 by
1
x
by
square.
x cube.
Very good. Minus 1 by x square. We have written this in properties. Okay, check all of you. Yeah. Now this part is common for this one. Means multiplying, right? Here we have sum. That's why. Now see how we are solving. U, that is x plus 1 by x all raised to x into
Log
log
x
plus 1 by x plus, see how I am going to write this one. This actually in the numerator, right? This part. This actually in the numerator. So x divided by, okay, x divided by x into x square
X cube.
plus 1 by x. Clear, right? Okay. Then into, this can be written as 1 minus 1 by x square. So x square minus 1 by x square. Is it clear? Check it.
Yes, sir.
In the next step, what is going to happen? See, in grade 10, I taught you complex fraction or compound fraction. Remember, you not see 2 divided by 5 by 3. Numerator is a single number, denominator is a fraction. So where you have single number, that you make as a fraction. How? by giving 1.
2 by 1.
So 2 can be written as 2 by 1. Now how to write? 2 by 1 into 3 by 5. Clear, right?
5. Yes,
Okay.
so
Check here also very carefully you have to do. X is a single number. So x by 1. This denominator is a fraction. So it is going to be x by 1 into x by x square plus 1. So this x will be x. You have to multiply with this x. Correct, right? Correct or not?
yes, sir.
Yes, sir.
Check it. X by 1 into x by x square plus 1. Correct, right? When you take the reciprocal. Yeah. So x into x is going to be x square. So see, you will get here du by dx is equal to x plus 1 by x raised to x into log of x plus 1 by x plus this will be x square by x square plus 1, okay, into x square minus 1 by x square. These two x square we can cancel. Okay. So du by dx is, can I write on the top?
Yes, sir.
Du by dx is equal to x plus 1 by x raised to x into log x plus 1 by x plus x square minus 1 divided by x square plus 1. Okay. Du by dx you got. When you write it in the final examination, okay, what you have to do? Main points in grade 10 also I told you the same thing. If there is a formula, okay, or important things, or these are the things you have to substitute last, right, in equation number 1. So these kind of things you just put it in the box. Otherwise, at least you give an underline for that. Why we are using that? Easily you can find out it is easily. Okay. When you want to write last in equation number 1, or if you want to substitute there, you can easily find out that. That's it, just to identify that, give an underline. For them also it will be very easy.
Do you have
Okay. Then go to the second one, B. Find dv by dx, all of you.
Done.
10 completed. B is equal to x raised to x plus 1 by x, right? Okay. That is x raised to 1 plus 1 by x. Okay. X raised to 1 plus 1 by x, right?
Yes, sir.
Okay.
Yes, sir.
Now take the logarithm on both sides. So log b is equal to log x raised to 1 plus 1 by x, then which is equal to 1 plus 1 by x log x. Okay, log v. Then differentiating both sides with respect to x, we get log v, that is 1 by v dv by dx is equal to here derivative first function. So when we apply here product rule, derivative constant, that is 0. Then derivative 1 by x minus 1 by x square. Okay. Multiply with the log x plus first function, that is 1 plus 1 by x into derivative log x 1 by x. Correct, right?
Yes, sir.
Then dv by dx is equal to v, we are transposing. So v into this I am writing first. Okay. So when I solve it, x into 1 x plus 1 So x plus 1 by x square, correct, right? Second part, check it. When you take LCM, x into 1, x plus 1 divided by x into 1 by x, that is x plus 1 by x square minus 1 by x square log x. So here consider x square is common. Okay. And give a resubstitution for v. V is x raised to 1 plus 1 by x. dv by dx is equal to v is x raised to 1 plus 1 by x, then into x plus 1
Minus
minus
log x.
log x all divided by x
X
square.
squared.
Yeah, over. Now you can substitute both the things in equation number 1. So it's going to be, therefore equation number 1 implies dy by dx is equal to x plus 1 by x raised to x into log x plus 1 by x plus x square minus 1 divided by x square plus 1. This is your du by dx. Then plus dv by dx, this one, just write down this one, x into 1 plus 1 by x into x plus 1 minus log x by x square. Is it clear all of you?
Yes, sir.
Okay.
Yes, sir.
So I will give you 2 questions homework. You have to simplify and send it back. Okay. Send to my WhatsApp number. Okay. Do one thing. Yeah. Send to WhatsApp number. That's enough.
Yes, sir.
Don't forget. Okay. Last class I said
Okay,
that
sir.
something, but you didn't do that. Okay. So today you have to solve. Today or tomorrow you have to solve and send it back. Not the questions. X raised to sin x plus sin x raised to cos x. Second question, x cos x raised to x plus x sin x raised to 1 by x. Okay. So 2 questions of homework.
Okay, sir.
Okay. So tell me, how is this logarithm differentiation? Do you understand, all of you? Are you
Yes, sir.
feeling
Yes,
any
sir.
difficulty means while applying properties, or are you feeling difficulty to identify the types of functions?
No,
No,
Tell-
sir.
sir.
No,
Clear,
sir.
right?
Yes, sir.
Okay.
Yes, sir.
So one more pattern is there. Thereafter it gets over. This one, logarithm differentiation. Then you have 2 more topics: parametric form and second order derivatives. So we can finish the chapter. But we will have extra questions. Don't forget that. So can we finish today this one? Can you wait for
Yes,
just
sir.
10-20 minutes? Okay, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
So right, next pattern of question. Okay, right. Find dy by dx of the functions. Find dy by dx of the function. Find dy by dx of the functions. X raised to y plus y raised to x is equal to 1. X raised to y plus y raised to x is equal to 1. Okay. So first identify what is the difference between the previous questions and this one. it is easy. There was not equation. There was just an expression only, right? You can check that. You didn't get
Yes,
any
sir.
equal sign there. But in this question, you can see it is an equation, clear, right? X
Yes,
raised to
sir.
y plus y raised to x is equal to 1. So whatever it is, you can't write this as y is equal to. Previous all questions you expressed as y is equal to. Clear, right? And moreover, here you have two variables. There you did not get two variables like that. Clear, right? Okay, x raised to sine x or sine x raised to x, like that way only you got it. But here you can see two variables. Moreover, it is an equation. Simple. This also we have to solve the same way. You have to take these functions as u and v. Functions. Constant you don't need to take, only functions. So choose first of all, let u is equal to x raised to y and v is equal to y raised to x. Therefore, how the given function is going to be? U plus v is equal to 1. Simple, right?
Yes, sir.
Okay.
Yes, sir.
Now, what do you want to find here? You want to find dy by dx. For that, differentiate both sides with respect to x. Here, x or y is not there. But you have to write differentiate both sides with respect to x. Right. Differentiate both sides with respect to x. So it is going to be du by dx plus dv by dx, that is equal to right side 1, derivative of a constant
0.
0. Equation number 1. Now same way how we solved the previous questions, the same way you want to find du by dx and dv by dx. Substitute here from dy by dx and du by dx and dv by dx. You will get some dy by dx in terms that you have to take outside and express it. So you will get dy by dx. Come on. Got it?
Yes, sir.
Solving, sir.
Okay. Easy, right? First u is equal to x raised to y, log u is equal to log x raised to y, that is y log x. Differentiating both sides with respect to x, 1 by u du by dx is equal to product rule. Derivative of y, dy by dx into second function log x plus first function y into derivative log x 1 by x. Then du by dx is equal to transposing u So u into you will get, I'm writing this first. So y by x plus dy by dx log x. Okay. And u is x raised to y. So du by dx is equal to x raised to y into y by x plus dy by dx log x. Simple steps, right? Okay.
Yes, sir.
Yes, sir.
Next, the same way, v is equal to y raised to x. So v is equal to y raised to x. Can I write directly? Okay,
Yes,
no
sir.
problem. I'll
Yes,
write. Okay. Log v is equal to then log y raised to x. That is x log y. Clear? Getting? Log y raised to x. So x log y. Then differentiating both sides. So 1 by v dv by dx is equal to product rule, derivative x1 into log x plus first function x into derivative log x 1 by x. These two
log
cancel.
y. It's log y.
Instead
Correct,
of
right?
log x,
Okay.
there's
X log y, yeah, correct. So 1 into log y plus x into 1 by y dy by dx. Correct, right?
Yes, sir.
Yes,
yes,
sir.
sir.
So dv by dx is equal to v, we are transposing, so v into log y plus x by y dy by dx. Last, dv by dx is equal to v is, what was v? Y raised to x, right?
Yes, sir.
Log y plus x by y dy by dx. Okay. Now you got everything. Just substitute that in equation number 1. These two things substitute in equation number 1. So when you substitute in equation number 1 implies du by dx. That is this one. So x raised to y into y by x plus dy by dx log x. Okay. Then plus dv by dx. dv by dx is this one. Y raised to x into log y plus x by y dy by dx. That is equal to 0. Is it clear, all of you?
Yes, sir.
Yes, sir.
Okay. Now what should we do? You have to multiply this into bracket, and all dy by dx term you have to bring on left hand side or right hand side, anywhere separately. Okay. Then leave dy by dx there, remaining all you transpose, you will get the final answer. So here I am going to multiply this thing. So we get x raised to y into y by x, okay, plus x raised to y into log x into dy by dx, plus here when you multiply this one, y raised to x into log y plus y raised to x into x by y dy by dx is equal to 0. In these two terms you have dy by dx, so other two terms you can transpose. Ayush, are you following? Seriously, did you get previous all steps? Okay. Yeah. Okay. Now from these two terms I am taking dy by dx outside. Okay. So dy by dx into, what is left over here? I have x raised to y log x. Okay. Plus My dear students, please listen for a minute. Can I apply any property here? Just check it.
Yes, sir.
Yes,
Y
sir.
is x minus
X.
1,
Which
sir.
one?
Yes, sir.
Y raised to power x minus 1.
Okay, very good. X raised to m by x raised to n form, right? Here power of y is 1. So x raised to m by x raised to n is x raised to m minus n. So this will be x
Y.
into y raised to x minus 1. Correct, right?
Yes, sir.
Okay. Is equal to right side. First you can write y raised to x minus, right? Minus y raised to x log y, then minus this we are writing the same way, y into x raised to m by x raised to n, that is x raised to m minus n, so y minus 1. Okay, so final answer we get minus, you can take outside, so final answer is dy by dx is equal to minus of y raised to x log y minus y into x raised to y minus 1 all divided by this one, x raised to
Plus,
y.
sir.
Y.
You've taken minus. Sir,
Yeah, tell me.
answer will be in the plus, sir. Plus y in
Okay.
numerator.
Yeah. Correct, right?
Yes, sir.
Yes, sir.
Yes,
Minus
sir.
we are taking outside, then remaining on plus. Got it right?
Yes, sir.
Okay. Then right next one. Y raised to x is equal to x raised to y. Y raised to x is equal to x raised to y. Any idea? Do you stuck in this question?
So not yet.
Okay. See, my question is this one. Should we take here u and v? Should we take in this question u and v?
No, sir.
No need. What is the reason? Tell me. When you compare with the previous some questions, we have seen in the entire expression, we have either in terms of sum of difference or something. Clear, right? In the previous question also, you see, when I take logarithm on both sides, log of sum, that was not defined there. Clear, right? That's why we didn't take. But here you consider, here directly you can take logarithm. No need to take u and v. So where we can't take directly logarithm, in such a situations we are using u and v. But in this question, directly we can take logarithm. Clear, right? So take logarithm on both sides. Now, when you take logarithm on both sides, log m raised to n, that is x log y
Y.
is equal to here y log x. Okay. Now, differentiating both sides with respect to x. Differentiating both sides with respect to x. So left side, product rule. Derivative first function, that is 1 into log y plus x into derivative log
Y
y,
by
1
Y.
by y divided by dx. Yeah.
With
Right side, derivative y.
so 1.
No. Derivative y divided by dx.
Oh, yes, sir.
They are differentiating function with respect to x, right? So derivative x is 1, but y is not 1 divided by dx. Okay. The right side product rule, derivative first function, that is divided by dx, into second function, log x,
X
plus
plus
first y, derivative log x, 1 by
1
x.
by X.
Okay. Now, in these two terms, we have dy by dx. So this you can take left hand side. This you can take on right hand side. Okay. So
Yes, sir.
x by y dy by dx minus dy by dx log x equal to right side y by x minus log y.
Y.
Okay. So here dy by dx into
X Y.
dy by dx into x by y minus
Oh,
log x is equal to right side. I'm taking LCM, okay? So it is y minus x log y divided by x. And here dy by dx into this will be x minus y log x by y. LCM is equal to y minus x log y by x. Okay, now you got the answer. Final answer is dy by dx is equal to, when you transpose, this y will be in the numerator, right? So y by x into, clear, right? Y minus x log y divided by x minus y log x. Tell me those who have any doubt. This one fraction divided by this one. So when you do like that, what you will get? On the right side, you will get what? This one into reciprocal of this one. That is y by x minus y log x. So by comparing, you will get y by x into this one by this one.
okay, sir.
Okay?
Okay, sir.
Okay. So one question I will give you homework. You try for tomorrow. Okay? Question. Cos x raised to y. Cos x raised to y.
Cos.
Cos x raised to y is equal to cos y raised to x. Exactly same question. Exactly same question. Right.
Okay,
Here we
sir.
have y raised to x is equal to x raised to y. But here, instead of that, trigonometric functions. That is only the difference.
Trigonometric function.
Exactly same way. Taking logarithm on both sides. No need to take here also u and v. Got it? Okay.
Got it.
Yeah. Now our last question. Okay. Come on. Right. This is homework. Okay. This question homework. So 3 questions you have to send after solving. Xy is equal to e raised to x minus y. xy is equal to e raised to x minus y. Come on, try. Xy is equal to e raised to x minus y. Please tell me, okay, those who are not getting any step, any time, anything, if there is any doubt. Vansh,
Yes, sir.
any doubt? Should I explain any step?
No, sir.
Did you get the previous one clearly?
Yes, sir.
Okay. Pankaj,
Yes, sir.
did you get the previous question?
Yes, sir.
Okay. Chirag,
Yes, sir.
got it. Ayush, Avardhan,
Yes, sir.
Arshia,
Yes, sir.
Chirag.
Yes, sir.
Yeah, Krish is remaining. Hi, Krish. Did you get?
Yes, sir.
Okay. See, many ways you can solve this question. Okay. Directly you can do. Differentiate both sides with respect to x, you can solve. Left side you will get the product rule. Right side e raised to x, the property is there. Then you have to find difference rule. Okay. So more easily, different 2-3 methods are there. There, the most easy one is what? Taking logarithm on both sides. Did you get the idea? Okay. Many ways you can solve. If I take differentiating both sides with respect to x, here you will get product rule. Derivative of x1 into second function y plus x into dy by dx, that is equal to derivative e raised to x, that is e raised to x minus y, then into difference rule, that is dx by dx1 minus dy by dx. Then you have to multiply this into this, then dy by dx you can take outside. Okay. More easily you can solve this question. What should we do? You have to take logarithm on both sides. Okay. So do all of you. Taking logarithm on both sides. So what you will get? Log xy is equal to log e raised to x minus y. Clear, right? Now, what is log x into y? Log x into y?
Log x plus log y.
Yeah, log x plus log y is equal to log m raised to n. That is, yes. Here, most important thing is, hello. The important thing is the point which you have to note, that is, see, do you know the use of logarithm? Where we are applying logarithm? What is the use of logarithm? Where we have higher order functions to solve that one. Clear, right? Okay, when a highest power you have, suppose if you have 2 raised to 1000, we can't solve that one. Clear, right? In this case, we can solve it by using logarithm. Okay, so when you have that kind of a function, suppose you have 2 raised to 5. Okay, so this you can write in terms of logarithm. How to write? Tell me. 2 raised to 5 is equal to, what is 2 raised to 5? 32, right? Okay, you can write this as a logarithm. Log
Log
32
32
to the
5
base 2, that is
2
equal to
by
5.
5.
So
Yes, sir.
5 is exponent here, correct, right?
Yes, sir.
Okay. Yeah. See, suppose if I write 2 raised to 0, what is 2 raised to 0?
So 1.
1.
1. Any number raised to power 0 is 1, right? So I
Yes,
can
sir.
generally write a raised to 0 is equal to 1. So you can write this log 1 to any number, that is going to be 0. That is why we have a property log 1 is equal to 0. Did you get the idea? Note it there, important one. Log 1 is 0. Okay. Now, my next question is b raised to x. Okay. For any number, can you make it a 0? Example, 2 raised to x. For any x value, Can you make it a 0, the result? Which is not possible, right? Not possible. That's what you can say. Log 0 to any number that is not defined. You don't have any number. There. Log 0 is not defined, not there. This is also important. Log 0 not defined. Okay. Next one. Next one. What is 0? Okay. What is 2 raised to 2? 1. 1 minute, 1 minute, 1 minute. What is 2 raised to 1?
2.
2.
2.
So you can write it as log 2 to the base 2 is equal to 1, right?
Yes, sir.
Okay. Do you know these two properties? Log 1 0, log 0 not defined.
Yes, sir.
Okay. See, what is a raised to 1?
A.
A.
So log a to the base a is equal to 1, right?
Yes, sir.
Okay.
Yes, sir.
100 raised to 1 is equal to 100. So you can write log 100 to the base 100 is equal to 1. So check everywhere. When these two things are same, everywhere you are going to get 1, right?
Yes, sir.
Yesterday we
Yes,
discussed
sir.
this one in the last class. When base is e, usually we don't write that. That means here if I write simply log e, it's a base is e. That means these two things are same. That's why its a result is 1. Okay, just note it there. E raised to 1 is equal to e. So you can write that as log e to the base e is equal to 1. Okay, so this result going to give 1. Did you get the idea? Theory part is clear, right, all of you?
Yes, sir.
Yes, sir.
Okay, so how can I write this one? Log x plus log y, that is equal to x minus y into this part is 1. Now differentiate both sides with respect to x. You will get 1 by x plus here 1 by y dy by dx, that is equal to derivative x 1 minus dy by dx. This you can bring opposite side. So 1 by y dy by dx plus dy by dx, that is equal to 1 minus 1 by x. Okay, Chiragar,
Yes, sir.
doubt anywhere, any step?
No, no.
Yes, 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 yes. This one. Doubt Chiragar,
No, sir.
seriously?
Seriously, sir.
Okay, yeah. So from these two, I can take dy by dx outside. So dy by dx into here 1 by y plus 1, that is equal to here x minus 1 by x. Okay. Now dy by dx into when I take LCM 1 plus y by y is equal to x minus 1 by x. When we cross multiply. So final answer is dy by dx is equal to earlier what we have done the same way. This one divided by this one. So this will be the reciprocal of that. So y by x into x minus 1 by what? Y plus 1. Got it? Okay. So this part you have to practice very well. See, questions are that kind of questions, you know that. If you get a question from logarithm differentiation, it might be for 3 mark or 5 mark. 3 or 5 mark questions. This much lengthy questions, right? Okay. The last part also some prove that questions are there that questions are also important that we can discuss in the next class tomorrow. Tomorrow, are you okay? Day after tomorrow you have exam, right? That's why I'm asking.
Yes, sir.
Sorry? Okay, so what about tomorrow morning?
Okay, sir.
Tomorrow morning, okay, right?
Yes,
Yes, sir.
Can you join at 10 o'clock?
Yes, sir.
Yes, sir.
Yes,
So
sir.
tomorrow there is no evening class, means the day after tomorrow you have exam. That's why tomorrow you will have it at 10 o'clock. Okay.
Okay, sir.
Okay, then bye.
Okay,
Good night.
Okay, sir.
Okay,
Bye, sir.
spend
Good night.
some more time. Okay, sleep around 12:30, 1 o'clock. Okay, go to all of you. Solve some more questions. You
Okay,
finish
sir.
this exercise. 5.5 you finish, then go to bed. Bye. Take care. Good night.
Bye.
Okay, sir.
Thank you,
Good
sir.
night.
Bye. 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 Okay. Good night.
Bye,
Okay.
Bye,
Good night.
sir.
Okay. Bye. 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 Bye.
Bye, sir.
Bye, sir.
Bye. Bye.